Welcome to this next video for the reverse engineering course of simplilearn security. This video is associated with chapter number 7 of the reverse engineering course. Till this point, we have only performed a superficial analysis of the logic of the applications involved. However, during this video, we are going to dig deeper inside some algorithms and analyze them in detail. So from this point onwards, we won't be doing any code modifications in order to solve the challenges. Instead, we will have to analyze in detail the algorithms and find a valid solution that will make the algorithm really validate the solution that we give to it. The reason why we do this is because we want to approach reverse engineering through this course in a very realistic way. Think about malware analysis. Usually, you will not have to do any code modifications, but what you are going to be asked during your everyday job is to manage to analyze in detail the malware and being able to write a report about its functionalities and any other detail that you might be asked to report. This challenge shares the same code for encrypting and decrypting the strings as the previous one. On the other hand, the valid code is not static anymore, or as we usually say, hard-coded inside the application. So in this challenge, there are two important algorithms that we need to analyze. The first one is the one responsible for decrypting and re-encrypting the strings on the fly, and the other one is the one which is responsible for the code validation. So let's start again by loading this challenge to Oli debugger. We run the challenge, we enter again a code of our choice, and we get again the same message that says that the code is not valid. This time, instead of using the stack in order to trace back the execution of the application, we're going to use a feature of Oli debugger. So we're going to pause the execution and then go on the call stack window. So this window here, it shows some recent calls that were made, and it operates as the stack, as a LIFO structure, which means that information at the bottom is the older one, and versus the top we have more recent information. And we can see here that there was a call to the message box function from this address here. So let's double click on this address here, and this is going to bring us in the code window. We can see here the call to the message box API, and what we're going to do is scroll up till the beginning of the function so that the next time we can break here and examine the whole function. Since this part here it's a part of this function that starts here, it's better if we break at the beginning of it so that we can examine all the conditions that are going to bring the execution in this call here. Okay, now at this point we have set a breakpoint at the beginning of the function, and if you see here, you can notice that the strings related to the message box that says that the code is not valid are visible, which means that at this point are decrypted, which is normal because the message box is being displayed, and we have paused the execution. So what we need to do now is to actually resume the execution and try again. So now we stopped at the beginning of this function, and it's time to start analyzing it in more detail. Now notice at this point that you can't see anymore those strings, which means that they have been re-encrypted again once the message box was closed. Let's right click here and follow it dump. And as you can see, apart from the title of the challenge, we can't see really anything else. But you can see that these pointers are going to be stored in these local variables here, and this is also constant. So we know at this point that if you follow in dump, one of the strings starts here and another one starts here. So probably these two are associated with the message box of the case that the code is valid. So these are pointers to addresses in the data section where all those strings are stored. So let's proceed by stepping over the instructions until we see something interesting going on. You might want to observe both the data and the stack window. You can see now in the stack window the code we entered. Let's continue. Now you can see here that EBX is going to be increased by 2, and EBX is pointing to our code in memory, which is in Unicode. So for each character we reserve 2 bytes. So now it's going to go through the whole of the code we entered. So every time it's going to increase the pointer by 2, so that it's going to check how many characters there are. So if you go in EBX following dump, you can see it here. So if we put this in Unicode, you're going to see it. If you see it in ASCII, it's because now this is a little Indian. So if you do hex ASCII, you can see that for each character there are 2 bytes, 00, 31 in reverse order. So now it's going to add EBX2, so it's going to read the next one. You can see EBX points on the next one, and it does this until it sees that the last 2 bytes are 0, which means that this is the end of the Unicode string. And you can also see that once this is finished, it compares EX with number 10. Now in this case is 5, and as you could see in this small loop here, in each loop EX was increased by 1. So this means that the final result in EX is actually the length of the Unicode string in terms of how many characters we have. So we have 1, 2, 3, 4, 5 characters, and it compares this with 10 hex, which is 16 in decimal. Now obviously this comparison is not true, so it's going to jump, and we arrive here. It pushes as a parameter to the next function that's going to call the local variable stored here, and it's this one here. So it initially stored the pointer in the local variable, so now it pushes the local variable which contains this address. And then it's going to call this function here. So let's see if something interesting happens. So let's follow in dump. Let's see what happens once we step over. You see the message box title is being decrypted. Now it's pushing the other pointer. It calls the same function again, and the rest of the message is decrypted. So we know that this function here is responsible for decrypting those strings, and this time we're going to analyze it in detail. So let's continue the execution of the application. We see the message box, so let's try again. Let's press F9 to run until the next breakpoint. So we stop here, and we're going now to examine what really happens in this function here that decrypts the strings. Press F7 to step in, and let's start stepping over the instructions. You see now that EX contains the address of the beginning of the string that's going to be decrypted. We see a loop here. So let's see what happens in the loop. Initially, as you can see, the first byte where EX points, following down, you see the first byte is 0C, is going to be moved to EBX, and this byte is going to be XORed with 5B, so the result is 57, and the result is going to be stored back in the same position. So it's going to substitute 0C with 57. Let's step over and see this. You see? Now this first byte has been decrypted. Then it adds to EX2, because remember this is in Unicode, so in order to reach the next one we have to add 2. And it's going to XOR the next byte with 5B, and the result is going to be stored in EBX again, and then substitute the next byte with the result, which is 61. So let's see this changing once we step over this instruction. As you can see, also EX points to this address here. So as you can see now, also the next byte is being decrypted. So let's start stepping over and see all the bytes being decrypted. So this is it. It's going to return back, and then it's going to push the next pointer for the next string to be decrypted, and it's going to call the same function again. Press F7 in order to enter this function again. Let's start stepping over the instructions. Now we see again that it's going to read the byte from the memory location that EX points to, so following down. So the first byte that it's going to read is 0F, and now it's going to XOR this byte with 5B, and it's going to substitute that byte with the result. And is going to perform the same loop again, and you can notice here the string being decrypted as we step over. So we can set a breakpoint here and run with F9. So we break once the loop has finished, and we can see the whole message decrypted. And you can select Unicode so you can see it clearly, or text here Unicode again so you can see the whole message, and also the title of the message box. So let's return back in order to continue with the execution. We can see now that it's going to call the message box API. We see that it pushed these two local variables. Here they are. This is the address where the message box title starts, and this is the one from where the text of the message box is located, the actual message. So it's going to call it, we step over, we press OK, and let's see now what happens again. It's going to push this address here, which is the one for the message title, the message box title, and it's going to do the same operation again, but this time it's going to pick up its decrypted character and it's going to XOR it back with 5B, so it's going to re-encrypt it. So it brings to EBX the first byte, it's going to XOR it with 5B, and then it's going to substitute the original byte with the result, with 0C as it was, and as you can see now it's going to re-encrypt the whole message title, and then it's going to call again the same function in order to encrypt also the message text. You can see as we run it, it starts the encrypting, re-encrypting on the fly everything. So we go back again and we exit the function. Let's run the application and we're going to try again. But before doing anything, let's think a little bit about what we know by now. We have already examined how the encryption and decryption algorithm regarding the strings works, and we have also seen that the algorithm at some point is going to check if the length of the serial we entered or the code or whatever is 16. So I'm going to change the input with 16 characters long one. So let's press check. We break on the beginning of the function and we start stepping over. We see here that is going to actually count how many characters we have entered. So I'm going to break directly here once the loop finishes. And you see now that it compares again EX with 10. This time matches. So this jump is not going to be executed. It's going to call the decryption and the re-encryption function again. So you see now the message box, the title of the message box, congratulations. It's going to call the same function again. You see your code is valid, has decrypted also the string. It calls the message box and says that our code is valid. So we can run the application, and what we know now is that in order to solve this application, or let's say this challenge, we just need 16 characters long password. For example, we can remove the breakpoint from here, and again we see that the code is valid. Pretty much a very simple algorithm. So during this video we examined a very simple verification algorithm, and we also had the chance to deal with some simple XOR encryption, which we saw that it was decrypting the strings, and then once it had finished using them, it would re-encrypt them back so it would hide important information from static analysis. Indeed, here you see that they are still visible, but this is because this window hasn't been updated. So if I click on it, you see it disappears. So that was it. I hope you enjoyed it, and see you in the next video.